So a lot of the imaging tools, the things like vendor tools, microscope things, software repair tools, the freezing, a drive, ATA components, smart, things like that. Those all suck. So what is wrong with these things? Huh? Cost money? Well, that's true. They do cost money. But besides that they cost money, what else is wrong with them? Is there anything really that different amongst any of these products? I mean, they all basically do exactly the same thing. But what are they all going to do when the drive fails?
Ruin your data.
Ruin your data. Maybe. It's possible. They're going to fail too. Almost all of those tools that are imaging things, when they actually hit a damaged disk that has more than a couple of bad sectors or something, they usually fail too. And they may even fail only on one bad sector. It may show you a little thermometer. It'll go across. It'll read where there's a bad sector. And then from then on, you'll just get this file that was full of zeros that a thermometer told you I was done, but not really have any data. So they typically fail on those drives as well. So almost all of those just like off-the-shelf commercial imaging products with a few exceptions. But for the most part, they will fail. So there are more robust, free / even some expensive ways of doing this so that you can actually be talking to the drive with bad sectors and still be able to copy stuff. There's some simple things that you could do like read a drive in reverse with PIO mode. You may actually get sectors that could not be copied other ways for free. There may be a way to do that. Usually you have to have a tool to redirect that. So there's a lot of these that I have in the top like MyRescue, DD Rescue. Those are free tools, Linux-based. Then there's Media Tools Pro, that's a Windows tool that's actually fairly expensive, like $300 or whatever. Speed Clone's like $40. Those will read drives in reverse and do a couple of different things. And there's a couple of dozen tools out there if you search for them correctly that you will find. And then there's even like the Ultimate Boot CD, which has some helpful tools on it. The important one to me that's on the Ultimate Boot CD that's free is MHDD. Because with MHDD, it's actually doing diagnostics where it bypasses, in some instances, the BIOS talks to the ATA controller. So even if your drive doesn't show up in the BIOS itself, you may still be able to communicate with the drive, scan it for bad sectors, or spit stuff out to a file, sectors to a file, so that you can actually parse them and do other stuff. So there is some possibility of talking to your ATA controller, bypassing your BIOS, because basically the BIOS that's on your computer does a very stupid thing with regards to drives. So there are other solutions with hardware, even some what I call low-cost solutions, but they're not cheap. The Deep Star Disk Imager, PSI Clone, other things that are forensics tools where people are already spending like $1,000 to $2,000 on TDIs or VOOM hard copies and stuff. Those really don't recover from bad sectors either, but there are tools that do forensics images that do recover from bad sectors. But I'm going to give you just a quick example. This is a small video, and basically what's going to happen is when FTK Imager or any software or anything is going forward on a drive, in a lot of cases it will fail because of problems with, like, for instance, cache on the drive. I covered that in some other talks, where cache is caching in advance on the drive, and if it hits a bad sector, it's either going to skip it, fail, or do whatever, and you're going to get chunks of data that it can't read, and most of the time, FTK Imager or any of the tools based on DD will just fail and never recover. And so this is a tool, this is a piece of hardware that's kind of like a BitTorrent. It doesn't care where the sectors come from, it doesn't care what order that they're in, but it'll go forward and try to read the sectors that are good as fast as it can, but in reverse, it will try to read the ones and fill in the holes of the sectors that were bad that it couldn't read the first time around, filling in those holes as it goes. So you're going to see from this. So, and I actually get a display in hex as it's doing this. All the brown ones are ones that were going forward that it failed. And so now going in reverse, I'm actually able to fill in these holes and actually see that in hex as it's going by, fixing a lot of the things in the disk. Now this particular tool is called the Deep Star Disk Imager. There are some ways to do this in software, like DD Rescue tries something very similar in Linux. If you understand how to use the tool and do what you need to do, you may actually be able to accomplish this. Unfortunately, in most cases, it's not like spitting this out in hex, giving you some good feedback or something, but you can play around with it. But this is just an example of ways to actually get around that problem. So when you're dealing with other tools like microscope and the vendor tools, like anybody run like, C tools or anything on their stuff? Anybody ever run that? Like, what does it tell you on your bad hard drive? What does it say? What? It
says it failed the test.
Yeah, it says fail the test, and it gives you what? Just like a generic number, right? It just says 523. Have you ever called tech support and asked them what that meant? What do they say? They go, oh, that's a generic error. We don't know what it means either. Just send it in. It's under warranty or something like that. That's about the best you get. So most of the time, those tools won't tell you very much either. Very few of those tools will actually give you like a real indication of what's wrong. Same thing for a microscope and the other tools where you pay, several $100s for a tool to examine your drive. They only are meant to work on working drives. They really don't work very well on damaged drives. It won't come up if you can't get it to actually initialize. What is your problem? And they are not going to help you out. So skip most of those things. They're not going to do a lot for you. Same thing here. You always want to save the state of your drive. You do not want to be messing with the drive in instances where a check disk, fixed disk, or anything else is going to make changes to your disk. I also removed SpinWrite from my list from a standpoint of don't use it because it makes changes to your original drive. It does not write to a destination disk. It may do the proper thing. Unfortunately, it doesn't write it to another disk. So if that disk dies or there's further damage to the disk, it's the last time you ever saw it. So unless they are going to change this to write to a destination disk, I just don't approve calling it data recovery software because data recovery software should recover to someplace else, not to the drive that you're actually, your original drive and what it is. So those you just basically need to say no. Frozen drives. Now, a lot of people go, oh, this is a myth, whatever. It really isn't a myth. It does work. Unfortunately, it's not the best thing to do to a drive. If you freeze a drive, basically the idea is there's something that might, maybe the board or something like that is damaged or the contacts have, moved away from each other from heat or something. And when you actually are freezing the drive, it causes everything to contract. And then maybe you actually have a contact or something that will survive for a little while till it warms up again and it dies. But at the same time, you may get even condensation or temperature changes that may do damage to it. So if you're lucky enough to get it to work and you're going to do that on your own, you got like 10 minutes maybe before the drive might die again and you're done. So if you're going to try that as a last resort, great. But it is not a great diagnostics process to just like throw it in the freezer and hope that it's going to work when you're done. But if you got nothing else, I just don't approve of it. USB. This is another thing I hear all the time. Is everybody goes, well, I'll plug this into my USB adapter. I'm trying to recover data, blah, blah, blah. You guys might have forgot, but USB sucks. USB sucks. When you plug this drive into USB, the ATA command set is not really in its full capacity and running and doing what it can do. It starts up a driver in any operating system. It basically starts up a driver to talk to the serial port, and it's a mass storage driver. It's a generic driver. It has no real fundamental control, so you can't do error recovery and you can't do ATA commands that are going to give you any good response. So there's not a lot you can do there. Trust me when I tell you, drives you might have now you've tried to recover from by plugging into a USB adapter, if you go find a motherboard and you slap it on the table for $40 and you put a power supply on it and try to recover from it connected to an ATA command set, to a controller, to SATA or an IDE, or go buy a RAID controller and plug it in, you'll be able to read those better than you ever were through a USB adapter. So don't be going, oh, my laptop's all I have. Well, whatever. I'm just saying that's not the best way to go. You could use eSATA if you needed to, but USB sucks. And these things, they're cheap-ass Chinese boards. Whoever's got, whatever the cheapest chip is today, and it's very, very simple stuff when they put it in these USB adapters or these USB external kits and stuff. You're paying like $13 or whatever for them. They're terrible. So skip those. Go get, you can even go on eBay and buy like an old Adaptec controller, like a 1200A, that's like $12 on eBay. And it will do a much better job at data recovery and error control than the crap that you're trying to use on USB. So basically, I want you to know you need to do anything that you're going to do for diagnostics with an ATA controller. There are some free tools out there that actually do some rudimentary, low-level diagnostics, like MHDD and Victoria. So again, I don't expect you to remember these things. Go hit the slides off my website, and those are the links to them, so you can go get them. You can switch from UDMA mode to PIO mode. You may actually get more. I actually did another talk on that, so you can go look at videos or whatever. And then you want to try reverse imaging in this process of actually trying to do something. So one of these tools for reverse imaging may work, and if you have money, spend it on a deep hard disk imager or another cloning machine or something. But in the process of trying to educate you, I want to talk about SMART as part of your diagnostics process, because a lot of people go, isn't SMART supposed to tell me that this drive is, bad or blah, blah, blah? Well, SMART sucks. You guys know this? SMART sucks. So I'm going to explain to you why SMART sucks. One thing, though, I want you to understand where SMART data comes from. It's very, very important to understand where the SMART data is written to from a diagnostics perspective and what it's doing, because it can be useful to you for diagnostics. It is useless to you in using your drive, but it may tell you a lot about the state of the drive, not because the feedback you get from SMART tells you anything, but the fact you could read SMART at all. tells you something. So here's the story. So your hard drive has basically a little mini operating system on it. It's as complicated as anything that you know, even in a normal operating system or any other car or whatever. It has similar post